Good morning, everyone. I'm Coenraad and I will be continuing with our presentation. Now, first we went and looked at if there is existing incubators in South Africa. Now, AgriProtein, an organization, opened the first production fly farm in South Africa. So the first production fly farm was actually developed in South Africa. And after raising $11 million, it started a chain of 40 more farms spread over the world. Some interesting facts on insect farms is that the saliva of waxworms contains enzymes that can break down polyethylene. So when using waxworms, we can actually use them to break down certain plastics. Polyethylene is a type of durable plastic that is hard to break down. In a study, we found researchers exposed a plastic bag, a polyethylene plastic bag, to 100 waxworms for 12 hours. This was the plastic bag example, and it was completely broken down after 12 hours. Now, for our black soldier fly farms, it is noted that the soldier fly farms flies can actually survive temperatures between 0 and 40 degrees Celsius. For optimal temperatures, though, we would want to keep it at 27 degrees Celsius, which is ideal for food consumption and also reproduction. Here at the moment is our electrical circuit that we have, which is an ESP with a DHT22 sensor, which is used to measure temperature and humidity. And also we have two relay modules, so we can later simulate heating in our enclosure by adding a heater bulb on one and a 12 DC fan on the other. And this will allow us to create heat and also use the fan to cool down to simulate heating temperatures conditions. Here's our bill of materials of everything we used so far, and as you can see, labor is unknown as we're not working it, so our labor cost per hour cannot be calculated yet. The total approximate cost is 774 rand. Now, in our app, to add a new incubator, the instructions are to press the sign up button on the login page down below, and you would then go and fill in your new username and your new password. If you press submit, your account will be added to our system. A demonstration of this will be shown shortly. To add a new incubator from the program side is you need to log in or sign in to your page, and then you press the plus button at the top of the screen, and then you can define your incubator name. That's all. For the incubator setup side, we would then have you change the account name variable in the code of the ESP to your desired account you would like the incubator to be under, and then you can set the incubator name equal to your desired incubator name. Keep in mind that if the incubator name over here and the incubator name you specified over here is different, or the account name under here and your account is different, then you would not be able to receive data. Testing. Sorry, I think I skipped the slide. No, I didn't. In our testing so far, we did response time of the app, and as of this moment, it is 3 seconds for the app to respond. This is for the ESP to be able to read data and then for it to show up on your phone. So when it reads data, it takes 3 seconds as of reading the data for the data to show up on your phone. Limitations to our app as of this moment: you can only have one account under each incubator unless the code is specified. So this means if you have one incubator, then only one account as of this moment can view it. The MQTT broker we use for the logins is not very secure, and when someone can connect to the MQTT broker, they could have access to your account names and passwords. So it is still somewhat secure because they do need to connect to the MQTT broker, and it is password protected, but once they get connection, then they have access to our passwords and our accounts. The project is still in the prototyping stage, so testing we do as of this moment, and statistics can vary from the future version. Now, difficulties we had in our term so far is we had a lot of side jobs. As when we will tell you about it, later on, you will see that we did a lot of 3D printing and a lot of site work for Automation Works training facility and also Automation Works. And in the end, we needed a lot of time management in order to compensate for the side jobs while doing our design project at the same time. The complex libraries we needed to use in order to complete our app also took a lot of time to learn. And once you spend 5 hours a day trying to figure out something, your brain doesn't always want to work further anymore. We needed to compensate for load shedding, because load shedding was also a very big problem, not only in our side jobs but also our design project. Once load shedding was initiated, sometimes the MQTT broker would go down and we would need to start new servers. And Ronaldo started the server and I started the server, and a lot of time was also allocated switching all the code from one server to another, to back and forth the whole time. Compiling the programs into an app also took a lot of debugging and was very complex to solve. And the right ESP data sheets were also hard to find, and they were needed exactly in order to create the right circuits. Successes we have had so far is the computer program can read real-time data. As we said, the delay is 3 seconds from when the node reads it and it's published through the MQTT server. As of this moment, we don't have a complete Android app, but once it is complete, the Android app would be easily compatible with iPhone or iOS devices. Connecting to devices through the MQTT server was successful, and we were also successful in publishing data back and forth. Now, lessons learned will be done by Ronaldo.